Please give a warm welcome to Dr. Sujit Day.
Hello, good afternoon. Today I'll be talking about something that all of us know is happening, but what is the impact on wireless networks, wireless communication? So if we look at the world around us, we see these developing applications, and there are four important things that are going on, according to me. One is that there's a lot of multimodal data that is being created by a variety of sources, sensors, and other sources. Second is that the applications that are going to use them are banking more and more on AI models, machine learning, deep learning models. Thirdly, that they are getting more and more connected, the sensors and the sources, to wireless networks, diverse set of wireless networks. And fourthly, that more and more of the functionalities are being done not at the source, but at the edge or at the cloud, which means that this massive amount of data is going to be transmitted over wireless networks. How is the wireless network going to handle this, the next generation of wireless network? Well, to answer that, we are looking at two things, two concepts. One is that introduce a data fusion and intelligence layer on top of the other network layers, playing a very vital role of fusing the data from the applications and the sensors and the network layers, and doing a lot of important things that are today done very ad hocly. For instance, authenticating the data, validating the source of the data, labeling the data, because you cannot label all this data manually, reducing the, selecting from the various multimodal data which modes are needed for that particular application and for that particular circumstance of networks and computing availability. And very importantly, hand in hand, selecting the models as we select or downsize the data or the modalities. So all this can be done at this new layer. We have been prototyping this and for a new set of applications related to vehicles, vehicular communication, vehicular fusion. And I just wanted to mention a couple of things here very quickly. One is that the vehicles, be they aerial vehicles, be they ground vehicles, they are generating more and more multimodal data, various different sensors. And this data is flooding the wireless vehicular networks. And so the way we are handling it is creating this, what we call the dreams framework, where we are choosing between the various models and the modalities. And when we choose among the modalities, and I don't know whether you can see the bottom of the screen, that we are doing much, much better in terms of precision, ensuring the precision of the models, but also the latency and QoS, what we call the QoS uptime. And the second concept that I wanted to quickly introduce is that the network layers have been very, pretty well known that they don't talk to the applications well. Now, in this new era where the applications are generating all this data, and if we have this data fusion model and the intelligence layer, then we have the opportunity of cross-optimizing between the layers and also essentially optimizing for multiple objectives, because we need to consider all these objectives together. Now, it's a tall order, but we are developing these ideas in our labs and also in the field. And one of the things we are also looking at is in this distributed, disaggregated network of tomorrow, where we have an Open RAN and RICs, how can we use them to actually develop this architecture, the actual architecture for this? And secondly, this needs a lot of distributed control and distributed optimization. How can we enable all this in the next generation of network? And where can we implement this data fusion and intelligence layer functions and the multi-layer adaptation tasks? And the fourth question we are asking is that, do we need to develop specialized platforms where we combine the fusion tasks, the fusion computations, together with the RF and the radio, so that this can be done much, much more efficiently than what the current architecture allows us to do? Thank you very much.